So let's continue with the different types of operators in Python. So the next one that I want to talk about is the logical operator. So logical operators are also known as Boolean operators, and these evaluate multiple conditions to determine whether a statement is true or false. So what this means is, let's take a look at the example and try to understand what this means. So if you look at this example, then this is the first condition that is being evaluated here, and this is the second condition. So this one returns true and the second one returns false, and then the operator AND is applied on this, so it returns false. And similarly for the OR operator, the first, let's say, condition evaluates to false and the second one evaluates to true, then it returns true. So now you can ask what would be the output, let's say, when both are false or when both are true and the AND or the OR operator is applied. So you can refer to the truth table that I have attached here, which shows you what should be the output in each of these cases. So when both are false, when one is false and the other one is true, and when both are true. If you would notice for the AND, like if even if one of the inputs is false, the output is always false. For the output of the AND operator to be true, all of them should be true. And similarly, if you look at the OR case, then you would notice that it is true for all the cases when even one of the inputs is true, and it is false only when all of the inputs are false. Let's talk about the NOT operator. The NOT operator is basically the negation operator, so it just gives you the opposite result of whatever the condition evaluates to. So let's say then condition evaluates to true, then it would return false, and if it evaluates to false, then it would return true. So that's what NOT operator does. And I haven't mentioned it, but so 0 here means false and 1 here means true. So that is true for all the coding languages, that's why it's given in zeros and ones, but yeah. Okay. So now let's go to the bitwise operators. So these operators perform operations on bits, and these are bitwise AND, bitwise OR, NOT, XOR, left shift and right shift. So let's take a look at each of these one by one. So starting with bitwise AND operator. So as I said that these operators operates on bits. So let's say you want to perform bitwise AND on 10 and 3. First you need to convert the decimal number that you are trying to perform the operation on to binary numbers. So 10 in binary format is 1010 and 3 is 0011. So now you start performing the AND operation on this that we saw earlier. So but this is going to be bit by bit. So when you perform AND operation on 0 and 1, it would result in 0. 1 and 1 would be 1, 0 and 0 0, 1 and 0 would be 0. You can also refer to the truth table that is given here. The output that you get, you convert that to decimal to get the answer. So here the answer should be 2, and if you go down you would see that bitwise AND of 10 and 3 is 2. Similarly for bitwise OR operator, again you have to convert both of these decimal numbers to binary format and then just perform the OR operation that we saw before. And for the bitwise NOT, this, let's say you're trying to perform NOT 7, then the binary format for 7 is 0111, right? And then since it's a positive number, there's a sign bit also that is assigned 0 here because it's a positive number, and when it's a negative number it's 1. So now since the NOT operator, what it does is it just negates, right? Then what would be the output is that 1 000 would be the output, and you also need to reverse the sign bit, so -1. So 1000 is 8, and since sign bit is 1, that means the output would be -8. Similarly, if you want to negate a negative number, then the sign bit would be 1, and -7 number is represented in a binary, and when you reverse this, or when you apply negation operator on this, it becomes 6, and the sign bit becomes 0, so this is +6. So then the next one is bitwise XOR operator. So again, there's a truth table that you can refer for XOR as well, and then just do a bitwise operation on each of these to get the output. Now coming to the left shift and the right shift, so how this works is that let's say you have a statement like 3 left shift by 2, so 3 in binary is 0011. So you start moving the bits left to the left side one by one, right? In the first iteration, when you move, it would become 110, and then if you move it again, then it would become 1100. Now if you do right shift, first time that you shift is it becomes 0110, then it becomes 0011, and then in the third time it becomes 0001. So now let's move on to our last operator, which is the membership operator. So membership operator, one which checks for the presence of something in a sequence like lists, tuples, strings, etc. So for example, here you see this thing, this is a list of characters. So if you want to check whether these sequences contain something or does not contain something, then these operators come in handy. As I have shown here, this one checks if A is present in this particular list. So this would return true. And then there is and is not operator, which checks if the left hand and the right hand side operands are the same. By same, I mean that it should have the same value as well as the same memory location. So in the example that you see here, x is y would return false, but x is z would return true, because in memory location it's pointing to the same value 5. So we looked at different types of operators in Python. Now the question may arise that what if there's an expression which has multiple operators, then how do we go about solving that expression, or how do we decide which operator to give precedence to? So you can take a look at the table that I have attached here and see which operator is given the highest precedence, and then decide which operation to perform first in an expression. So that's all about the operators. Now going to the bonus section and continuing the discussion on the operator module that we were doing in the previous video. So you can take a look at the list of all the functions that are available in the operator module corresponding to each of the operations that we have learned so far from this table. I'll attach the link of this in the description section. And I also want to talk about the in-place operators. So operator module provides in-place operations, so you can just add an I in front of all of these functions to perform the in-place operation. So let's go to the IPython shell and see how it works. So let's say you have a variable x equal to 5 and you perform the in-place operation, and you say x equal to operator dot I add x comma 10. So this is equivalent to saying x plus equal to 10. Similarly, you can perform other in-place operations as well, and like I and, I concat, etc. So that's all I had on the operators, and if you have any further questions, please feel free to write down in the comment section. Thank you.